color pen out, ready to grade homework as soon as we're done? No? Get ready. 3 multiple choicey ones, right? Why didn't you like number 37? Oh, did you like it? I figured a lot of you wouldn't like it. Why was this a little bit messier than normal? But, okay, so what's bad about it? I agree, it's rough. Why is it rough? Complex fractions? Do you guys not think complex fractions are hard? Hello, good morning. Are we going? Okay, complex fractions are kind of nasty, right? Okay, if they're not, then no big deal. I'll just keep going. So 4 over 4. Multiplied by 2 over 2. You end up with... What's wrong? Oh, I suppose so. I was just thinking it was a complex fraction anyway. But yeah, it could have been 1 over 2. I end up there with that guy. And you end up with the final answer of... What's wrong? Why is there no 2? He simplifies with the 4s. Yeah, because we have a square root of 4, which is 2, and then 2 over 2, and it cancels out. Or some of you brought the 2 down and realized that the 2 simplified. Either way, you end up with your final answer of positive. When would it be negative? If that was not a sign inverse, but a... Got it. Letter E. Secant inverse. What's that formula that you guys hopefully used? I just did U prime, but yeah. 1 over... how come there's... Uh-oh. How come there's no absolute value of x squared in any of those? Does the absolute value have any meaning if x is squared? Ah, it's redundant. And x squared will always be positive, so we can basically ignore the absolute value and say he's already positive all the time anyway. Then we can reduce with the x on the numerator, and we end up with a final answer of, I'm seeing A just in case my brain's being funny, but yeah, right? Dun, 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 dun. And last but not least, easy cheesy, if they ask for the slope of the tangent line, they just mean derivative, right? So hopefully we found dy dx is equal to u prime over, this one's the nice one, right? U squared plus a squared, plugging in such that x is equal to 1. And we end up with 2/5, letter C. How'd you guys do? Yak. Oh, yeah.
I don't understand why, with 1 over 1 minus x squared, I don't understand why, like if you multiplied 1/2, why it all go on the top. Because I did it as 1 over 2 times square root of 1 minus x squared over 4. And then I did 4 over 4, and I canceled out the 4. So I ended up getting B.
Hold on, I'm checking. You put the 2 in the denominator.
Yeah.
And then over, oh, you forgot to square root the 4. I think that was it. Did you square root the 4 to be 2?
So what I ended up having was 1 over 2 times the square root of 1 minus x squared 2 squared. And then so it simplified that.
Yeah.
And then if I had, I did 4 over 4 to cancel out the fraction.
Good.
So then I ended up getting 4 over 2. Oh wait.
You see it? Because that 2 squared became a 4. The 4 over 4 got a common denominator.
I have to multiply the 4 to that 2.
Oh.
Wait.
Multiply by the 2.
I'm confusing myself. So what I did there when I multiplied the 4 over 4, I got 4 on the top and then 2 on the bottom, and then the square root of 4 minus x squared.
Oh, you multiplied here by 4 over 4. Got it. You forgot the square root. So technically the square root's on the top and the bottom because it's over the whole thing. So you shouldn't have multiplied by a 4 over 4. You should have multiplied by a 2 over 2.
It's because the value of 1 is like 4 over 4, right? 4 over 4 reduces to minus 2.
So what I did is I got a common denominator before putting the two together, and then that led me to 1 over 2 times the square root of 4 minus x squared over the square root of 4. So my common denominator is 4 minus x squared over 2 squared is 4. Square root at the top, square root at the bottom. He ends up being a 2. So actually we can just simplify, but you could have multiplied trying to get rid of stuff. Thinking that was a 2, and if I'd multiplied by 2 over 2, that guy would have gone away because of square root of 4. But then those 2's would have reduced. So I think you were doing the right idea. You were just thinking he is a 4, so you were trying to get rid of him when, in all reality, he's really just a 2. That kind of makes sense? Yeah, square root's over the whole shabam. Shabam. But I multiplied by the 2 over 2d, but kind of doing what you were doing, like trying to cancel out stuff. EAC. Okay, let's grade. E. That's fun. Oh, come on. You should like E. That's not the one I was trying to do. But you will see that one. Pearson text. I have the homework open just in case we need something or others. But first of all, let's just grade what we got. Let me full screen it so we can see it. There's 4 and 8 and 12? Yeah. 4 and 8 and 12. And as you guys grade 4 and 8 and 12, I'll come over and read Mr. Strike's addition to the Share the Hope wall. Mr. Strike. I talked about it because I helped with I did a Devo this morning, and I mentioned our Share the Hope wall. And I mentioned how all of the quotes are good, but I think we need some more actual hope on the wall. So he said, from Romans 15:4, for everything that was written in the past was written to teach us, so that through the endurance taught in the scriptures and the encouragement they provide, we might have hope. And he double underlined hope. ... So read the Bible, my friends, for in those pages, ... mixed with faith in Jesus, ... you will find great hope. Signed, Philip A. Strike. A? Is it Anthony? I don't know what his middle name is. Andrew? Can I scroll down? How are we doing? Oh, you didn't do chain rule?
No, I did chain rule, but I just did it like as though it was like 1 over. So like I took the derivative of the bottom, and then I just put.
So you did that chain rule, but not that chain rule. Well, it ends up looking a little, oh, they did make it prettier. -2 over blah, blah. Number 12, final answer is 1. You get it? You know how to do the work. Get the final answer. Although it's a negative, make sure you guys see that. But I think you've learned how to see my answer keys by now. Good. Number 16, number 38. Oh, is that it? Nice, go team. I'll let you guys go ahead and grade, and then you guys reach out with any questions you have, evens or odds. Why didn't the absolute value go away that time? Yeah, that could be positive or negative. I have to leave it. Hey, is this something kind of similar, though? Super similar? I have an over, you would need to do -4 to get a common denominator. You'd have an over root 4. Over root 4, which would be over 2. The over 2 down here could cancel with the 1/2 there, but you still have this guy. Wait a minute, I couldn't pull the x out. How come the 1/2 came out and flipped to the numerator because it was 1 over 1/2? Does 1/2 have a positive or negative sign attached to it if you pull it out? The 1/2 doesn't need to stay in the absolute value. He is himself. The 1/2 was able to come out. The x had to stay in. And number 38 is D. So just in case you guys need to see that in between. I feel like a couple of you might have gotten lost. ultimately they can reduce because the x still remains. Then you can multiply by 2 over 2. And the 2 and the root 4 reduce. The d, that's kind of like the one that you were thinking. So the 2 and the root 4 reduce, and then 2 times negative 1 is negative 2. Okay, sorry. Questions on odds, evens? I got distracted for a second.
Yeah,
Naomi?
25.
25. Maggie, anything earlier than 25? Okay, so starting on number 25. Directions say equation of a tangent line. Oh, you have to get y by itself? That's kind of lame. Correct to the nearest thousandth. Who would do that? Oh, well. Let's make an equation of a tangent line that's correct. And so for this one, you just have to take the derivative of this guy. It's a little nasty because it's an x over 4. But we would do 1 over the square root of 1 minus u squared times u prime, which the 1/4 could be up top or it could be next to. You end up with 1 over 4 times the square root of. I would do little common denominators, not of 4. Bummer. What do I need common denominators of? 16. So multiplying 1 by 16 over 16, or seeing 1 as 16 sixteenths, I get 16 minus x squared all over the square root of 16. Remember, we can split up fractions. Multiplication, division, we can split up with square roots. Oh, hey, 4 and root 16 ends up just becoming, they simplify, they're the same thing. Such that x is equal to 3. 3 squared is 9, 16 minus 9 is 7, 1 over root 7. Ugh. Equation of the tangent line, if we're trying to get y by itself, I'll just do it our old-fashioned way. Remember, to get the y, we have to plug in to the function. To get the m, we just steal our derivative, which was 1 over rad 7. It's not pretty, but get y by itself, it's right. But for your y1, you got to go plug it into the original function. For your m, you're stealing from your derivative, and then x1 is the guy they give you. Maggie, where are we going next? $29, they gave us, a linear combination of cosine and 3x. Find f inverse of 1 and f inverse prime of 1. Yeah. But why are they having you find this? Because you can't plug 1 into, well, what am I talking about? If you're trying to find that derivative, that'd be 1 over f prime of f inverse. I need more than the 1. I need f inverse of 1. So they're really just having you solve the pieces you need for the derivative. So f inverse of 1. F inverse has the point of 1 comma, we're trying to find the other thing, right? But the x of the inverse is the y of the original. So what we needed to do was figuring out the original function, or looking at the original function. Huh? Was it a decimal answer? F of 0, oh, because cosine of 0 is 1, duh. This is what we talked about last year, that you guess and check. If it was an AP question that was not in calculator. If it was calculator, we could graph it, and we could graph 1 and find the intersection. Or we could subtract 1 graph and find the 0. We could use our graph. But if it's not a calculated question, x must be a nice number. So 0 would have been the first thing I would have tried. Silly me, I thought cosine of 0 was 0. In that like half second I thought about it. But cosine of 0 is 1. 3 times 0 is 1. So therefore, that's going to be true when x equals 0. So therefore, if x equals 0, y equals 0. So therefore, when I come down here, how do I finish the problem? I plug in 0, which would be 1 over negative sine of 0 plus 3, which would be You guys agree? Deba.
So I got one there.
Yeah.
I feel like I did it incorrectly.
Oh.
I did the derivative of f inverse. And so I got the sine of 0 plus 3. But I did like 1 over sine of 0, sine of 1 plus 3. So I ended up getting 1/3.
Oh, you plugged in the 1, thinking that all you had to do is plug in x is equal to 1, forgetting that you were supposed to go find the y. What you messed up is when you saw sine of 1, you're like, oh, it must be 0, instead of realizing sine of 1 is some nasty, weird decimal-y thing. Because think like 0, pi over 6, pi over 4. 1 is somewhere awkwardly around pi over 4, pi over 3. Somewhere pi over 3-ish, because 3.14-ish over 3-ish is almost 1. So yeah, that's what you thought. You were like, oh, I don't know, it's 0. But yeah. So is it, I mean,
Sine of 0 is decimal, sine of 1.
sine of 1 is a decimal. Sine inverse of 1 we know, because that could be pi over 2. So sine equals 1 at an angle, but sine 1, like 1 radian is like awkwardly here. It's somewhere around 60 degrees. Having to do with like 1 radius around the circumference of. Anyway, sine would be some nasty. You could plug it in radian mode, and then you'll see some weird decimal pop out. Maggie. Well, the problem is the inverse. Like if we were to switch the x and y, like you can't mathematically get y by itself. We could graph it in parametric mode and see what it looks like, but we couldn't actually solve for y. So then I think where your brain's getting stuck just a little bit. Well, wait, do you do this? Do you switch x and y like Riley? Okay. So then if you took the derivative, wouldn't you have gotten 1 equals negative sine of y plus 3 dy dx? Which leads you to, here's the problem. It needs the y of the inverse. I only have the x, so you have to go finding him to plug in.
So is it okay to say that because the f of 0 is 0, 1 for the inverse?
Yeah. I forgot that you guys had done that in letter B. Sorry. I could have made that a lot easier. But yeah, since you have 0, 1 for the original, it's 1, 0 for the inverse. So then I just need to plug in the y of the inverse, which brings me to the same place. Anything else? Evens or odds? We're okay? 38? Oh, next page, sorry. I would say the easiest way without using a triangle, could have used a triangle, but the easiest way would have just been to use the formula. Tangent inverse of u. So then 1 plus 3x squared times 3 would get you pretty quickly. 3x times 3x is 9x squared. That's why I would say letter D. Oh, so then it didn't match up. Yeah. So easy to do. How many of us have copied down a question wrong at least once in our lives? Yeah, that's it. Copied down something wrong. I bet more hands will go up. Is that it? We're done? All right, notes open. Derivatives of exponential and logarithmic functions. Done with the book, done with the homework solutions. Got it. There's some pre-cal going on this page, huh? Not a lot, just a little bit. Not a lot, just a little bit. You guys get the title, 4.4, Derivatives of Exponential and Log Functions? exponentials and logs. There are just forever cards that go with that, right? But does that mean that we necessarily remember them all the time? Maybe some of us. Where does it get hard with exponential and logs? E? Nah. ln? Nah. Where does it get hard? A to the u, b to the u, log base a, log base b. Ooh. Bulimbu. 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 We're on homework 13 next. Okay. Huh. Yeah, I actually kind of like it because it defines E, and that's not something that we do very often. No, that one actually doesn't really come up with their way of defining E. Because you guys know that E shows up in nature a lot. But as far as a definition of how you could actually solve for E, it's the accumulator function of 1 over t, which I guess in some ways would make sense, but that's okay. Oh, you can't see what's going on down there? From 1 to E. 1 to E of 1 over t dt. Welcome. How do you solve for x? ln of both sides. So ln of 7 and ln of E, x plus 1. Would you guys have put parentheses around the x plus 1 when it came down? Hopefully. ln of E is equal to 1. So x is equal to ln of 7 minus 1. Oh, no, don't do that. That's awful. Do negative 1 plus ln of 7. We know why, right? If you write it the other way, you might think it's ln of 6, and that doesn't really work out. But the nice thing is ln of e to the x, ln of e can undo each other, e to the ln can undo each other. Why? Because they're all inverses. But down here at the bottom, interesting, accumulator function from 1 to e. You would solve it out. It would make sense, but it's another way of defining e. I just thought it was interesting, since you guys have seen integrals before. But kiddos, do we know e? Is he okay? Yeah, he's not bad. Because without going into too much work, we can just go ahead and say dy dx, derivative of e to the u is e to the u times u prime, which is when. So that when we get to these problems down here, down below, all we have to be careful of is the u prime, really, right? So then dy dx of this one's going to equal e to the u, no big deal, rewrite them. But what else do I have to remember? U prime is just 2. So why do so many of us make mistakes when it comes to something like letter B? Yeah, maybe you don't realize that it's a quotient rule, or maybe you don't realize it's a power rule. What? Some of you make it harder than it needs to. Hi, you just keep on messing up today. E to the -3, some of you could save so much time if you just see it as a power. Now, I don't always agree. Maggie, is it you that keeps on making like complicated stuff -1 powers? I don't think it's always useful. Like, I don't think it's always useful to make everything a -1 power, but if it's just an x, I mean, come on. How easy is it just to say e to the -3 over x times +3 over x squared, right? Bring down the -1, make it a -2. Just be careful. Some of you use the quotient rule when I think you don't need to, and then you might mess yourselves up a little bit. Yeah, bottom d top minus top d bottom all over bottom squared works. I just don't know if it's necessary. But where does it get messy? When we have e's? Nah. It gets messy when we have b's or a's. And so we're going to review, why won't he move down? There we go. So let's review a little bit of pre-cal when we're dealing with a's and with b's. What if we have a to the x? What if we have log base a? I think most of us are probably fine on that page now, right? How would we get x by itself? Just using these properties of how an a to the power of undoes a log base a, or a log base a undoes an a to the power of. What can we do down here for solving for x? Yeah, so we could do log base 3. Not that we couldn't do ln. We could do log base 3 of both sides. Over here we get x is equal to log base 3 of, why am I going to write this as why would I change 81 to be 9 squared, which is 3 to the 4th? What's so nice if I have a log base 3 of power? What happens? Yeah, and all I have is x equals -4. Now, is this going to be nice and pretty if the bases don't match? No. Which is why we don't always do log with the yucky bases of both sides. Sometimes we do ln instead just because it's going to be bad anyway, and ln's easier to deal with. But if the bases do match, life is a whole lot nicer and simpler. So how would we undo a log base 2 of x, just mathematically speaking? Yeah, 2 to the power of both sides. 2 to the negative 16. 2 and 2 is 4. 2 and 2 is 4. 4 and 4 is 16. Dun, 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 dun. So are they impossible? No. Are they nice? Not so friendly. Are you? You don't have to use log base 3, but if you use an ln, it's not going to look near as nice as -4. Oh, you could have done it back here in the 1-to-1 property. I don't have that written. Yeah. You could have just set 3 to the x equal to 3 to the -4, x equals -4. But I was just further cementing the fact of how to undo a 3 to the. But you could have done an ln, brought the x down and divided. You just wouldn't have known necessarily what that was. So then how do we use that pre-cal in order to help us when needing to derive some guy like this? So we have y equals log base b of x, which we don't really like, right? We are getting to where we have little derivative rules about what we can do. Oh, did we? We never wrote down ln, did we? Did we not write down ln at all? We just wrote down e? Whoops. Oh well. What do we do for with y equals ln of u? Sorry, guys. Yeah. dy dx is equal to 1 over u times u prime. Wow, that slide just got lost somewhere. Lo siento. There we go. So we could use other properties from pre-cal, like log base b of x, using the change of base formula is ln of x over ln of b. So we could change the form of this entirely to y equals ln to the b, or ln to b on the side. Why am I doing it that way if really the formula is... Who's b? So what's ln of b? So can't constants, coefficients just come out in front? Oh, so how would I take the derivative of this guy? Wouldn't I just take the derivative of ln of x, but wouldn't I also have the coefficient ln of b? Just a few of you guys switch up who goes where, the x and the b. The x just comes from the derivative of ln as 1 over x. But in order to change bases to an ln, which is the guy that I want to deal with, I need to offset by a 1 over ln of b because of the old-fashioned change of base formula. Some of you have it memorized, and it's fine. You're going to keep on having it memorized, or at least you'll review it a little bit and it'll get stuck in your heads. But for just a few of you, keep on switching things up. It's really just 1 over x times 1 over ln of b. And this guy's not that much different. This guy's not that much different, except I can't change a b to the u to an e to the u. But what I can do is take log base b of both sides. And I would end up with log base b of y equals u. And I could derive this implicitly. Then I would get my 1 over y ln of b dy dx is equal to u prime. And how would I solve for dy dx? I would multiply by y ln of b times u prime. And who was y to begin with? dy dx is equal to b to the u. So both b to the u and log base b of u are super similar to the other special exponential and special logarithmic functions. Log base b of x has a 1 over x. B to the u has a b to the u like e to the u does. They just have these extra little ln of b's, and you guys need to get straight where they go. So that way we don't mess them up. Does that make sense? So then with that, we have those derivative rules that some of you just do not like, but need to know. Derivative of b to the u is b to the u times ln of b times u prime. Derivative of log base b of u is 1 over u ln of b times u prime. This section also brings back logarithmic differentiation. This section also brings back logarithmic differentiation. And it would be fun if we could practice these formulas and make sure we're masters at it. And it'd be fun if we could do the AP practice at the end. But what's true about class? What's true about class? We're out of time. Aw, too bad you guys want your test on Wednesday anyway. You guys good if we finish the section on Monday? Homework's not due until Tuesday and we have a test on Wednesday? All right. Then if you're so fine